In today's lesson, we are introducing the topic of optimization. So Unit 16 is all about optimization. If you remember from grade 11 math, we looked at optimization where we're trying to determine a maximum or minimum value of a quantity. And there'll be maybe some certain restraints on the problem. So sometimes you'll be given the equation, sometimes you won't. In this example, oops, I don't need that. In this example, we have a tour operator who is selling tickets on a bus, and the price of the ticket is $130 per person, and there are 60 seats on the bus. So she would like to obviously maximize her revenue. So in this question, the revenue is given. Remember that revenue is number of items times the price. Right, so we've got number of items. So however many tickets I sell times the price is how I bring in money. So this question equation is done for you. We know that the price of a ticket is $130. Let's put number of tickets first, just to be consistent. So there are 60 seats on the bus, and each seat is $130. So that's where those values come from. The price of the ticket is going to be raised $5. And every time she raises the price, she loses 2 customers. And remember that X always represents the number of items. So we want to figure out the ticket price to maximize revenue. So I'm going to expand this equation so that we can find the derivative. Let's just put the x squared first. We'll add 300 minus 260, so that's 40. Since we want to maximize revenue, so if you remember grade 11, you would have had to complete the square to find that vertex. We can just find the derivative, which will give us our maximum revenue. And then we can just solve for x. So we know that the maximum would occur when the derivative is 0. And so x will be 2. So that means that we have to raise the ticket price twice, and that means that we will lower the number of seats. So the new number of seats will be, we had 60, we're going to lose 2 seats twice. So now we're going to sell 56 seats. And the new price, the original price was $130. We're going to raise it by $5 twice. So now the new ticket price is $140. So part A says, what should the ticket price be? That's part A. Part B says, will there be any empty seats? Yes, there will. We're only going to sell 56 tickets now. So there would be 4 empty seats. So pretty standard. We did this in grade 11. It's nothing new. It's just that we can do it a little more efficiently now because we know how to do derivatives in order to find maximum and minimum values. Okay, in this question, it's a little dated because it talks about Copps Coliseum, which we know is First Ontario Place now. So let's fix that. He charges $100 for each ticket. He usually sells 50 tickets. He wants to obviously maximize his revenue. So you're always looking for that word maximize or minimize to know that it's optimization. And so he wants to maximize revenue. So we're going to look at number of items times the price. Number of items is how many tickets he's going to sell and the price that he will sell them at. And so originally he was going to sell 50 tickets and the price was going to be $100. He's going to put the price of the ticket down by $2, and it will mean that he's going to sell 1 extra ticket. So if he lowers the price, he figures he can sell more tickets, but he'll get to a point where that's not going to be cost effective. So this is my function. I'm going to expand these 2 brackets. That's a minus. And so my price, or my profit, or sorry, this is revenue. My revenue function is minus 2x squared plus 5,000. And I want to maximize, so we'll find the derivative, which is minus 4x. And then we'll solve for x. So we get x is 0. That means that he's already at his maximum revenue. So he does not need to change the price of the ticket to maximize revenue. He's already going to make the maximum amount of revenue that he can make.